So, good day, class. This is yung Dynamics of Rigid Bodies naman, Lecture 2. From rectilinear, we're not going to be talking about curvilinear kinematics, meaning we're going to talk about the paths that's curved, the particle traveling in a curve motion. So, here's the outline. So, basically, we're going to be talking about rectangular components ng curvilinear kinematics, pagdating sa displacement, velocity, and acceleration. We're going to be talking about projectile motion, horizontal and vertical motion, displacement, velocity, and then acceleration. So basically, projectile is a combination of horizontal and vertical motion, but technically you can solve it by components. The horizontal component part and the vertical component part. Again, hopefully you still remember your differential and integral calculus theta. Okay. But we will be primarily using a lot of formulas in dito, but the formulas that we established no rectilinear kinematics would still be applicable dito. So let's go with it. Okay, so some definitions lang muna. So with curvilinear kinematics, refers to the let's go with the laser point dito. Refers to the location of the object along the straight line, and it's also the study of a particle where its motion goes along a curved path without considering the causes of motion given time. Okay. So if you remember yung position vectors natin before, we also refer for those with curved ones, position R, it refers to the location of an object along the nonlinear path at any given time. Okay, so ito siya. Here's the particle. And then, of course, just to remind us, displacement again refers to the change in position of an object at some time interval t. So that we call that delta S. In this case, yung delta S natin magiging delta R. So if you recall this is kind of like it kind of looks like our dot product and cross product samples before, but this time it's curved path naman. Okay? So ito yung initial, and then pupunta siya dito, ito yung magiging final. Okay. So in this case, the delta R or the change in position, basically, yung magiging displacement natin na yan will be final R minus initial R. Okay. Again, we're just recapping some concepts lang naman ulit. So again, this is velocity. So if you recall, velocity is simply the ratio of the displacement. In this case, we'll be referring displacement now as delta R. Since we're talking about curved paths na, hindi na siya linear. So from delta S to delta R na tayo. And then describes the rate at which an object changes its position. So do remember this formula. So again, just like before, velocity could be positive or negative depending on the direction at which the object is moving. So moving to the right is positive, moving to the left is negative. Okay, we can also calculate yung average speed, meaning yung scalar quantity lang ng velocity, which is in terms of position divided by time interval t, delta t. And then also we have this one. So meron tayong instantaneous velocity rin. So its specific rate of change with respect to a single point in time. Dito siya. And then, so mapapansin nyo na palitan lang yung S natin ng R dito. Kasi it's referring to nonlinear path and it's a curvilinear motion na. Okay. There we go. Next, we also have acceleration. Ganun pa rin naman siya. So again, it's just simply the first derivative ng velocity, or basically the ratio of the change in velocity with respect to change in time. So just like velocity, it's also a vector quantity. It can be positive or negative. We also have instantaneous acceleration, where you can get the instantaneous acceleration by the first derivative of velocity or the second derivative of position. Okay, ang siguro nadagdag ko lang dito pagdating sa curvilinear kinematics is the idea of called hodograph. Basically, it describes the locus of points for the arrowhead of the velocity vector in the same manner as the path S describes the locus point for the arrowhead of the position vector. So ito yung difference nila. Okay? So it's just hodograph is just the yeah. May kita mo siya usually sa mga weather patterns. Yeah. Here's the shortcut para maintindihan na. So just a quick comparison lang naman. Our S now will be R. So essentially yung velocity natin, we're just gonna for computation's sake, I'm just gonna denote this letter V lang naman. Pero in this particular notation, I made it like small v, but it doesn't really matter. Pero right now, with rectilinear kinematics, with curvilinear kinematics, so velocity now is delta r over delta t. So that means yung derivative lang naman ng dr over dt yan. Then of course, our acceleration is delta v over delta t, so dv over dt. Okay? So just small v lang naman, right? So in terms of its components, so ito siya. If you recall yung Cartesian vector notations natin, yung I, J, K, they're just unit vectors that pertains to what position in 3D space they are. So in this case, position R is a vector which could be represented in 2 dimensions and in 3 dimensions, I, J, and K. So when we're talking about position vector, Cartesian vector notation niya is x times I hat plus y, j hat, and plus z, k hat. And to get yung magnitude nito, we just have to get na lang yung the square root of the sums of the squares of x, y, and z. Something that we have discussed before, no, during our statics of rigid bodies. I hope you still remember those. Pero right now we're gonna be using yung basic lang naman, yung most likely yung magnitude niya. Okay, because sometimes pinapahanap yung, okay, you're given yung dimensions nito on the x and y values niya, pero ano yung magiging magnitude nitong acceleration or vector, which I will be showing you later. So in this case, if the problem is not required, hindi naman sinabi na kailangan Cartesian vector, we won't be using Cartesian vector naman, okay? So next up is velocity, ganun rin, can be represented in the x, y, and z, I, j, k hat. Okay, so essentially, just like to, our velocity vector lang naman here is just the first derivative of position with respect to time. And this can be represented by vx times I hat plus vy, j hat plus vz, k hat. Okay, hindi ko lang nalagay siya na I hat siya dito, pero pag susulat natin, kailangan I hat or j hat or k hat para makita natin kaagad. So pag makuha natin yung magnitude ng velocity, so essentially yung magnitude niya is simply the square root and the sum of the squares ng x, vx, vy, vz. Okay? And then of course, yung direction nito is uv equals to v over v. Pero technically, pag na-common na yung x and y, when you're dealing with two x and y dimensions lang naman, kahit i-tangent inverse mo na yun, pwede na rin yan eh. Makukuha mo na yung angle at which they're being projected, which is normally the case pagdating sa problem solving, okay? So, mapapansin nyo dito, this is yung Leibniz notation. So, Leibniz, I'm not sure if I'm butchering. So, this is yung Leibniz notation, pero mapapansin natin, first derivative siya, velocity is first derivative ng position. And position could be relatively x, y, or z values rin ang naman. And itong x, tapos may dot sa taas, this is yung Newton notation. Okay? Ito yung Isaac Newton's notation ng derivatives. Okay? So don't be confused about it lang naman. It's just that it's still derivative, pero it's just being represented lang differently. Okay? Next is naman sa acceleration, ganoon rin. So in this case, may kita nyo dito, hindi ko lang nagawang small b, pero acceleration is the first derivative ng velocity, which is also a second derivative of positions dito. So dv over dt siya, which is represented by, in this case, 3 vectors rin, 3 dimensions. Ax, I hat, plus aay, j hat, plus az, k hat. And then yung magnitude nito is simply the square root of the sums of the squares ng ax, ay, and az. Next up is let's try some sample problems na naman how we're gonna apply it. For example, we're given this particular sample problem. At any instant, the horizontal position of the weather balloon in the image below, which is this one, is defined by x 80 feet. Ito siya. So ito yung function niya. Where so ito yung x niya, and then defined by x equals 80 for feet, where t is in seconds. If the equation of the path, yung y, is x squared over 10, determine the magnitude and direction of the velocity and the acceleration when t is equals to 2 seconds. So, ang mangyayari dyan, we are here to determine yung magnitude and direction of the velocity and the acceleration when t is 2 seconds. So, how do we do this? Okay. So, we first, let's just write down muna yung mga given natin. We know that it's required yung velocity. We know required yung magnitude basically ng velocity and yung direction ng velocity and as well as yung acceleration. So, magnitude and direction na rin ng acceleration. So, we're also given yung y, yung equation ng line na to, which is x squared over 10, and x equals to 8t and 8t feet. Basically, t is in seconds. So, we're here to determine yung velocity and acceleration at t equals 2 seconds. So, how do we do this? So, recall that the velocity is the derivative lang naman ng position over time, or basically, forgot how to read this. Basically, x, first derivative of x, position x. Okay. Yep. Forgot the dot dito. So yeah. And then all we have to do is just substitute what x is. So x is 8t, and we will get 8 feet per second. Okay, that's one. But that's just the x component since we're dealing with 2 dimensions lang naman dito. For our sake, we're primarily dealing with 2 dimensions lang naman. Okay, so there we go. The next up is we can get na yung acceleration as well neto since all we have to do lang is just get the derivative of vx and we will get ax. 0 feet per second. As you can see here, I'm dealing it by components. So I'm dealing it with x values muna and then yung y values muna. So next up is paano naman yung by and ay. We will use yung chain rule. Now, chain rule lang naman here, you may refer to your appendix on how to explain it, pero and you can do a quick review rin pagdating sa differential calculus nyo. Pero chain rule is just basically we're gonna derive it the second time around. So mag-second derivative tayo. Okay? So basically ito, y equals to f, y will be a function of time. In this case, y is x squared over 10, and then x will just replace that with 80. Okay, so in this case, magiging 6.4t squared, and then vy here, so just y prime lang naman dito. Okay, y dot, that will be 6.4t squared, and then times 2t. All we have to do lang naman dito is just, so makikita mo dito, in-express ko muna yung y in terms of function ng t. And then, I substitute that to get the derivative of vy. And once I got that, which is 12.80, I substitute yung 2 seconds dito. Kasi we're here to find yung velocity and acceleration at t 2 seconds. So, here we go. 2 seconds. And may substitute tayo dito. So, 12.8 times 2 is just 25.6 feet per second. Next naman is we can do the same thing pagdating naman sa acceleration wherein we have to the first derivative of vy naman dito. So for ay, that will be vy derivative. So that will be d over dt 12.8t, which will give us 12.8 feet per second squared. So there we go. So that's at 8 supposedly. So that's a minor edit lang. So, are we done? Not yet. Kasi we're here to determine daw yung magnitude and direction. As you can see, these are components ng magnitude natin. Okay? So, the next step dito is just getting yung magnitude ng velocity and acceleration by simply getting yung so ito yung given natin from the previous slide. And then, all we have to do lang is just get the square root lang and the sums the squares ng vx and Vy. So here, the magnitude ng velocity is 26.82 feet per second. At the what direction? So that will be tangent inverse and Vy over Vx, which is 72.65 degrees. So we do the same thing with the acceleration, wherein the magnitude ng acceleration natin is 12.8 feet per second squared. And where else? And the direction is tangent inverse AyAx. That will be 90 degrees. Okay. This particular problem. So here we have a jet, our path of a plane. So for a short time, the path of the plane, shown below, this one, is described by y, yung equation on line, path basically, as 0.001 x squared in meters. Now, there should be a period. If the plane is rising with a constant velocity of 10 meters per second, determine the magnitudes of the velocity and acceleration. Determine the magnitudes of the velocity. If the plane, when it is at y equals to 100 meters. Okay, so this is a different kind of problem we're in. Di siya in terms of, di siya with respect to time. Okay, so before we really tackle the problem, of course, we analyze muna what we have muna. So, there we go. And then next. So, given natin dito is, of course, we have an equation of the path, which is y equals to 0.001 x squared in meters. And then, okay, and then, we have yung Vy, which is rising, okay? So that will be, yun yung clue natin. Rising siya at constant velocity at 10 meters per second, okay? And then we also have yung mga required. We are required the velocity and acceleration, basically yung magnitudes nila. And not necessary na yung direction, pero we can get it if we want it. And at y, at position y, equals to 100 meters, okay? So, solution natin dito. Okay, so, first things first, we have to convert, we have to recall that, V is basically the ratio of position over time, and we kind of have to make sure that it's with respect to position, because we need to find that y equals to 100, okay? But I think we can get time rin naman dito rin eh. Okay? So kaya ni-rearrange ko yung equation ko. Sorry, let me repeat that lang, ano? So we can actually get we can still represent this at with respect to time, but we still have to solve it. Eh. So if you recall this, y is equals to 0.001 x squared. There's also y at 100 meters. So we can get x here at 100 meters, which is 316.2278 meters. Okay, so we now both have yung x and y values natin dito. And recall yung velocity is simply the ratio ng position over time. We can rearrange the equation as to y equals to vt. And in this particular in this particular setup, we can actually determine time. So here, so y would be 100, and we have vy. In this case, this is vy. That's 10 meters per second, okay? Yeah, let me write that down. That's 10 meters per second. Wait lang. Let me just highlight. No. I need a pen. There we go. So this is yung Vy. So Vy. And given na siya. So alam na natin na given siya. And then, let's go back to our laser pointer. So that's gonna be 100 equals to 10 meters per second times t, and then so solving this, the 100 divided by 10, t will be equal to 10 seconds. Hindi t equals to 10 seconds. We're able to find out that t is equals to 10 seconds by dividing 100 with 10. Okay, so meters magka-cancel, so will give us t equals to 10 seconds. From here, we're now able to. So this is, since we know now in time natin, we can usually solve this like the first one, the example problem 1 natin, and we can solve na by components. So we can start by Vy, y prime. which is first derivative of position y, d over dt, where y, that will be 0.001 x squared, which is 0.002 x dot. Okay. Okay. And then let's keep it that way. And then of course we will this one where x here is technically bx kasi that's position x eh. Okay? So Vy naman dito is 0.002x. We can rewrite that as, yeah. So that will be 10 meters per second. That's given. And 0.002 galing yan sa derivative na 0.00x. And then x prime. I'm just gonna call it x prime na lang, okay? And then this one is, where's x dito? X is 316.2270, which is the kuha natin initially here. And then in meters times, ito is first derivative the position x, which is also equal to Vx as stated here. Okay. And then from here, makukuha natin yung Vx, which is 15.8114 meters per second. Okay? Which, in this case, makukuha na natin velocity kasi we have Vx and Vy. Simply the square root of Vx squared plus Vy squared, which is 18.783 or 18.71 for that matter. Okay na yung 18.71. Next up naman is yung acceleration. So that's yung velocity. So for acceleration, it's kind of the same thing rin naman. So remember, ax and ay, remember that they are the first derivative of respective velocity nila. So in this case, we have Vy here. We already find that out earlier, which is simply titignan natin yung back equation natin dito. So Vy here is 0.002x first derivative of x. So we just gonna use that lang dito, substitute dito. And we will have this one. Where x here is Vx. And then the second and then the first derivative of Vx is simply ax. Okay, again, we're still using a chain rule, hence why the equations are in this manner. So in this case, we will be able rewriting equation ay is equals to 0.002 times Vx, the sums of Vx squared plus the product of ax and x. In this case, since ay naman is 0, remember at constant velocity, meaning acceleration is 0 since Vy is constant naman. So here magiging 0 to, and we can simply transpose and get ax. So yun yung unknown natin. So we just simply substitute yung known values natin ng velocity sub x and x position, which we got earlier. And we have ax here would be negative 0.7906 meters per second squared. In this case, makukuha natin yung magnitude niya, which is simply the square root of ax squared plus ay squared equals to 0.79 meters per second squared. Okay? Alright, next up naman is about projectile motion. So projectile is, ano ba muna yung projectile motion? Projectile is an object that travels on a curved path. Okay, so here we are. It has two components. Meron siyang x components and then y components. Hence, these vectors, if you recall them, can be separated to its components. For example, initial velocity natin as initial velocity x component and then initial velocity y component. So, and then yung tinatawag na path dito, that's yung trajectory na tinatawag natin. So in solving projectile motion, we ignore yung effect ng air resistance. And then, of course, yung acceleration that we're going to consider here is constant, being the acceleration due to gravity, which is a equals to g. So specifically, negative g. Okay? So let's break it down ng konti. Okay. Okay, saan tayo? So we have yung x-axis, which is horizontal motion. Again, positive, going to the right. So since ax is acceleration sub x, or horizontal acceleration, it's practically 0. So meaning constant yan, unless otherwise specified. So recall yung mga formulas natin before pagdating sa kinematic equations natin. If you remember this, if we're going to convert it in projectile, it's going to be this one. Okay? Plus, if it's already negative dito, you don't need to put yung negative 9.806 stick dito because it's just that's gonna mess up yung equation. Okay? Or in this particular case, it's 0 naman. So, yeah, it happens. So, we have naman yung y-axis, which is in vertical motion. So, going up is positive. So, AY here is negative g, 9.807 meters per second squared downward. So, recall yung equations natin before. And then, pag kinonvert natin sila in terms of projectile motion, it'll be like something like this. So, remember, naka-negative na sila since it's already applied the sign ng negative g, okay? Which is 9.807 dito. So, negative 9.807. Okay? So, no need to add yung negative 9.7 sa negative g na yan, okay? So, that's kind of confusing dun. So, to further understand this, let's try to solve more problems dito. So, halimbawa, we have a sack slide. So, ito yung sack. Sack yan. Slides off the ramp and shown below with a horizontal velocity of 12 meters per second. Okay, so horizontal, so tama siya. If the height of the ramp is 6 meters from here, from the floor, so we can refer to yung origin natin. So ito yung x, y, so meaning yung total displacement natin from A to C here would be negative 6 kasi pababa siya below the origin line. And nasa third quadrant tayo, the fourth. We determine the time needed for the sack to strike the floor at the range R. So basically yung horizontal distance natin dito, or horizontal position natin dito in this case. Okay? So where the slacks begin to pile up. Okay. So we need the total time. Okay, and A here is G. Okay? So here, okay, let's try identifying given natin. So we have yung Vx natin dito at 12 meters per second. And we have the Sy, which is here at negative 6 meters. Because it's below dito, no? And X and Y natin. And then G here is negative 9.806 meters per second squared. Okay, required natin dito is yung total time from point A to point B. So, there we go. So before anything else, if you want to analyze further, so more or less ganito yung tsura niya. So may V tayo dyan, A to B. And we're here to find yung, we need to find R then at some point Okay, so here, the range R then. So we need to find R rin pala. So kailangan may R tayo dyan. And there we go. We need to find R. There we go. Laser pointer. Okay. So the first thing here is we need to find T. So to solve T, remember the equation. So we consider first yung vertical motion since most of it we have enough data doon. So for vertical motion, so here we have displacement. Okay. And we know na in displacement natin at point A is 0. So we already have a given there. And we know what displacement natin at point C, or in this case B, that will be negative 6. So we already have that. Okay, and then we also have initial velocity natin, which is VAY somehow, and we have G. So we can use yung equation na to. YB equals to YA plus VAY, yeah, the Y component of VA, tapos plus half AC t squared. So in this particular configuration natin, let's do further analysis. Most likely yung YA natin is 0 since this is yung point origin natin, just like I said earlier. So that will be 0 kagad yun. So, and then yung YB natin here, so either C or B naman dito, that will be negative 6 meters pa rin. And then since ang tawag dito, since ang gravity natin is negative g, which is constant, this makes our, kung constant acceleration natin, this means there's no change in velocity dito, making our VAY 0. So, our new equation would be something like this. There we go. So we just isolate t to get the total time TAB basically, and we get something like this. So negative 6 times 2, and then divided by negative 9.806. Notice that I don't particularly like to use yung standard formula na ganito. I still prefer using this one. Wait now, may correction yata dito. Yeah, there's a correction lang dito, guys. So let me just auto-correct it lang. There we go. What slide is this? Anyway, so this had been a contention rin before, no? So as you can see, I don't normally use yung formula lang may negative 2g kaagad, but instead I just use kaagad yung, in this case I'm just gonna copy lang this one. There we go. And then I'm just gonna, editing ko na lang. Yeah, there we go. And then going back to slide. There we go. There's a reason why, kasi it gets kind of confusing pag nilagay mo agad negative 2g, although yun yung presented before. Ako, I would rather use this, then sa ako papalitan yung acceleration constant ko ng negative g, which is negative 9.806. Then saka palang mababago yung positive sign dito into negative. Kasi most of you will probably make a mistake dito pag ito yung ginamit nyo. So I prefer you guys use to as your basis. Now, it's just a matter of magiging x lang siya or magiging y, kung magiging projectile siya or not. So, it's just a matter of labeling lang. So, pero for computational sake, mas gusto kong gamitin ito kasi there's less room for mistakes. All you have to do na lang is just substitute yung AC with negative 9.806. So, yung positive mo dito, magiging negative. Dito kasi ina-assume ka agad na alam mo na negative siya. So, hindi mo nalalagyan ng negative 9.8066 dito. So, lalagyan mo negative 2 times 9.86. Pero, that creates confusion So for me, I would rather use yung base formula pa rin para less yung formula na tatandaan ko, which is the same formula na ginagamit natin sa sa rectilinear kinematics. So there's no problem on using it lang naman. So with this one lang rin. Except here we're dealing with projectile. So we have yung x and y components dito Okay, now let's go back to the problem. So saan na tayo? I believe we're here. There we go. So we already have yung time. So hence, di naman ginamit ko. So it's basically the same lang naman with yung SFX5, since we're considering yung vertical motion. So this is SFY equals to SFY, and then this is yung SIY plus VIYT plus 1 over t ACT squared, wherein yung AC natin dito, since for vertical motion, magiging negative g. So yung positive here, magiging negative eventually. Just like this one. Diba? So when we're gonna find this, t now is equals to 1.062 seconds. Okay. All right, and the next is we're not yet done. So we still have to find yung range. So range lang naman here. So we have to consider naman yung horizontal motion. And remember, pag horizontal motion, so we're given yung initial velocity. we can probably using formula neto for range. If you recall, yung xf equals to xi plus vit. Yeah. So in this case, we have yung initial position, which is 0, and we have yung initial velocity, which is 12 meters per second. We now have yung total time from TAB. So here, TAB, 1.062 seconds. And all we have to do is just find lang yung final position, XF. Okay? For me, again, it's a matter of labeling. I believe I relabeled it. So if you want to be strict about your labeling, so we use yung XB equals to XA plus VAX. Basically, yeah. Para to avoid confusion lang naman. Okay? So substituting everything, and we will find out XB is... Okay, there we go. XB, which is yung R natin, which is 13.2744 meters, which is 13.27 meters. Okay, for the next problem, let's try the classic projectile problem. Here naman we have a chipping machine. Okay, so it's projected at an angle, but somehow magpas yung buong trajectory niya, nagpas dun sa frame of reference natin under the x-axis. So here we have point origin here. This is the y-axis. It's elevated at 30 degrees. We have a magnitude at initial velocity, which has a magnitude of 25 feet per second. We have, which is at this point, this is 4 feet above the ground. And this is the pile here, the pile of wood chips here is at height h. We're given the range of 20 feet. Okay, so the pile from the wood pile and the wood chipper and chipping machine. Okay, so basically, this chipping machine is designed to eject wood. Yep, at 25 feet per second initial velocity, and again, sabi ko nga, it's oriented at 30 degrees from the horizontal. And we're here to determine how high h is. Basically, the chips strike the pile if at this instant they land on the pile at 20 feet from the tube. Okay, so let's solve this one by one lang. So again, we identify muna what is R given dito. So as you can see here, not sure if you guys, I hope you guys remember how to evaluate this further, but given that it's the initial velocity is 25 feet per second, and then that it's oriented 30 degrees from the horizontal, we're not only given two variables dito, but we're also given two additional more, because we can break it down to its Vx and Vy, if you could recall yung statics of rigid bodies natin. So we can break down it into its rectangular components, which is in x and y values. So meron tayong Vo, Voy, Vox. Okay, so that just means initial velocity lang naman. In this case, we can find it out computationally. So that's simply 25 sine 30 degrees for the y component, 25 cosine 30 degrees for the x component, and the answers are 12.5 feet per second and 21.6503 feet per second, respectively. So here we need to find yung h in feet. So we're given yung range natin, or basically yung s sub x natin at 20 feet, and then g natin here is negative 32.174 feet per second. Okay? So recall yung since we have yung initial velocity natin dito, and we have yung we already have yung final position natin dito at 20 feet, and we have initial velocity, we can, I think, determine yung total time it takes for the wood chip from its outlet to the pile. Okay, so we can label that as total time OA, and we can use this formula. There we go. And all we have to do lang dito is just substitute the known values. We know that the initial position S sub xi is 0 at point origin, and SS sub x is 20 feet. We know Vxi at Vox, at Vo, basically, Vo cosine 30 degrees. That's 25 cosine 30 degrees. 21.6503. Okay? And all we have to do now is just isolate the time here. There we go. And that will be TOA, total time, is 0.9238 seconds. Why is that important? Gagamitin naman natin siya when we're solving this in the vertical motion naman. Okay? So for H, we consider yung vertical components natin dito, vertical motions. So what are involved? So we know that involve yung acceleration due to gravity. We know involve yung VY component, VOY component. And then what else? All right. We don't need the entire 4 feet dito, so it's gonna be H. So SFY natin dito basically is initial. This is final minus initial. So 4 minus basically it's H minus 4. Okay. So all we have to do is basically use this formula. Okay. So for the there we go. So recall your SYF. Yeah, that's a lot. So which is equal to SY sub I plus VYI T plus ACT squared. Wherein yung initial position natin at the Y component is 0 here. And yung final component natin, as you can see here, this is yung final position niya. So that's technically H minus 4. Yun yung pinaka-final niya talaga. So whatever yung final position nito at this point, okay, minus 4. Okay. Okay, and then yung AC natin here, simply negative 32.174 feet per second in English tayo. Okay, all we have to do na lang is just substitute yung mga values natin dito. And let's not forget, VYI here is simply 25 sine 30 degrees dito. So nakuha na natin siya as 12.5 feet per second. There we go. And then all we have to do na lang dito is just isolate this for here, transpose natin sa kabila, and then solve it. Then the answer here will be 1.8187 feet or 1.82 feet. Okay. Now, that's just solving mathematically lang naman using yung mga grand formulas natin. First few problems natin is about recognizing yung essence ng differentiation natin and how to solve it yung via calculus, by getting the first derivative lang naman and second derivative of position, and the application of chain rule. You may check yung shortcut method dun. I showed you the shortcut method because I don't see the need for you guys to go through all over algebra again. So if you want to take a review about yung chain rule, you can just visit your book and check the appendix. It's there. Next one here is, what if we're asked to generate yung equation of the line? So we have here is a problem, okay? So if the x and y components of a particle's velocity is given at the function Vx is equals to 32t meters per second, and yung Vy natin is 8 meters per second, determine the equation of the path y as a function of, with respect to x, basically, as a function of x, where x is 0, y is 0 when time is 0. So we're given several values dito, no? So here we are. Ito siya, ito yung given natin. And we're required to find yung equation of the line, basically. So if we're gonna put this into perspective, we're gonna draw this. The graph should probably look like this, you know? Well, we don't know pa yung equation on line. So essentially, ito lang naman hinahanap. So just to represent it visually lang naman. So not necessarily ito yung path ng line, but we don't know yet. So depending paano natin susolve yan. So if you recall natin yung equation natin, which is yung velocity is simply duration of position with respect to time, and acceleration is duration is the derivative of velocity with respect to time. Okay, and all we have to do lang is to let's find first yung we can determine yung so we're given yung time at 0, so there must be a time final dito. Okay, so that will be in terms of dt rin. And here we can determine yung dx and v dt dito by getting the integration of both sides lang naman dito. And we will get the equation, we substitute it. So for vx, that will be 32t dt. And then for dx, it will be 0 and x since we're given yung boundaries naman natin dito na integrations natin. So 0 to a particular time t. So in this case, yung x na yung v natin dito, which is for vx, is 32t meters per second. So that's it. So magiging 16t squared siya. Okay. Yeah, so basically one half times 32 t squared basically. So naging 16 and then x dito. So that's our x, and then for the vy naman, all we have to do na lang is just get this one and vy dy, so vy times dt. So vy natin dito is 8 meters per second, so 8 dt, 0t, so that will be 8t and equals to y. Okay. So to get the equation of the line dito, which is y equals to f of x, all we have to do is equate this, x equals to 16. We need to get t. So basically t here is basically square root of x over 4. And we substitute that to y, and we will get y is equals to 2 square root of x. That's basically your equation of line. Y is equals to, that's the equation of line, which is y equals to 2 square root of x. So that's one way of particularly solving this particular problem lang naman. So for this particular problems, you really have to be creative rin and determining whether you go for derivation or integration. So in this case, you're trying to determine the equation ng line, and you're given some boundaries dito. More often than not, you're gonna integrate. Okay, for the next problem, we have a track, and then for this racing event, and then it's designed to so that the rider can jump off the slope at 30 degrees from a height of 1 meter. Okay. So during a race, it was observed that the rider remained in mid-air for 1.5 seconds. Oh wow! Determine the speed at which he was traveling off the ramp. So we're trying to determine the initial velocity natin dito, and the horizontal distance are gaano kalayo yung distance traveled niya with whatever initial velocity he started off. Then of course, and then the maximum height he attains. So yung pinaka-max height niya, okay? He attains. So basically, yeah, max height he attains from the horizontal. So here we're gonna write down our given again. So we know na we're required with a speed, a speed at which is traveling off the ramp. So we're required to find what's VA dito, So and yung VA niya can be separated into two things, VAY and VAX. Right. So that's 30 degrees, as you can see there. Hindi siya yung 30 degrees dito sa gilid. It seems that the author got lazy, pero makikita niyo yung arrows na to. So here, from this point and then this point, so meaning, yung loob na to, yan yung 30 degrees natin dyan. Hence, VAX natin dito is VA cosine 30 degrees. VA is cosine 30 degrees, and then yung VAY natin dito is VA sine 30 degrees with a total time traveled of from TA to TB, which is 1.5 seconds, and then yung YB natin here, we can get that as negative 1 meters naman dito. Okay. Next up is we're required to determine yung magnitude ng VA and yung range, and then of course yung total height H or YC, yung maximum height attained. So to solve it, let's find muna yung VA. So for VA, let's consider this particular equation. Let's consider yung vertical motion, since we mostly have yung data na yan. We know for certain that horizontal. Let's consider yung horizontal motion. Kasi for sure, we have yung actually, scratch that. Let's consider muna tong formula na to. We know that SF is equals to SI plus VA VIT plus ACT squared, where AC is equals to G at negative 9.8066 meters per second squared. We can convert that. So considering na yung vertical motion neto at y, so YB is equals to YA plus VA sine 30 degrees, which is VAY, plus negative G at T squared, so which is 9.8066 meters per second squared. We already have time T, which is 1.5 seconds, so we can determine, we already know YB, and YB is basically negative 1 meters dito. YA, however, so nagsimula siya dito, so that's 0 meters eh. So considering those values, ito yung final position niya minus initial niya. So we simply have in total displacement na dito. We have VA sine 30 degrees dito, and where VA is unknown, we have time T, which is 1.5, we have G, so we can determine VA. And all we have to do is rearrange the equation. Just like so, cancel, and where is my mouse? There we go. So we are left with, so meters to, and we'll cancel out, so eventually magiging meters per second yan. So our VA should look like this. And VA is simply 13.3766 meters per second, or 13.38 meters per second. So now that we know our VA, we can determine the rest. So for example, for range, we're gonna be using yung VAX natin dito. So we can use yung formula na to, which is yung XB equals to XA plus VAX TAB. I'm just putting labels lang naman dun. So in this case, we already know XA, which is 0, but we don't know yung final position niya, which is R dito. Okay, so XA should be point here, and then XB is yung total niya, so which is yung R. Okay, we know VAX. VAX is, we can get na yun via VA cosine 30 degrees. And TAB is still 1.5 seconds eh. And then, cancel, and then we get meters. So XB here is 17.3767 or 17.38 meters. Okay, the last component here would be yung max height. So if you remember yung problem sinolve natin during rectilinear, yung rocket problem, at max height, we know very well that yung the final velocity natin, or yung VCY natin, will be 0. We know very well that yung initial position natin is 0. Okay, and then so of course involved dito yung G rin, which is negative 9.806. So in this case, we recall yung formula na we're talking about yung position, and yung there's no time involved dito. So the only variables we are left with is a velocity, acceleration, and time. Hence we have this particular formula. Okay, so this is yung velocity with respect to position. Okay, so that will be VF squared equals to VI squared plus 2AC SF minus SI, or delta S. So we equate that into yung labelings natin dito. We have this one. So we have we have VCY, which is 0. We know that kasi at max height, 0 na yung velocity. We have VAY kasi mayroon tayong initial velocity, which is VA sine 30 degrees. Meron tayong AC, which is G at negative 9.8066 meters per second squared. And YC, yan yung hinahanap natin. YA is simply 0. So we substitute yung equations natin dito to find yung YC. Well, YC here is technically H minus 1. There we go. Okay, and then substituting everything and then canceling, we will have H as 3.28 meters. All right, the next lesson is about, it's another part to this curvilinear kinematics. It's about normal and tangential components. All right. it sounds complicated, and if you read the lectures in advance, it looks complicated. But again, when you read the lectures in advance, when you solve some problems, it's actually quite easy. And more often than not, it's gonna be direct substitution. So this is probably ito yung dagdag lang pagdating sa memorization yun ng equations. But I don't encourage you to memorize yung formulas. But if you're familiar already with the rectilinear kinematic equations, you're not gonna be lost. So let's put some definitions dito ng konti. Normal and tangential components. This refers to the analysis and representation of motions by breaking down to its perpendicular. And here, formally, we have you horizontal and you meron tayo horizontal and vertical motion. Here, we're going to be talking about yung perpendicular, normal, and yung parallel or your tangential components. So more often than not, we have a path here. The particle travels in a path, and if you ever went to Baguio or any zigzag, your car will travel in a particular curve. It will find yung proper apex lines na yan. So, and yes, this is also used in racing. And so what's the proper path dun? What's the proper entry and exit? And you'd be surprised that we can actually calculate rin yung velocity, exit the curve. So this is pretty exciting if you're a sports fan or you're a racing fan. Okay, so we have here yung origin, which is located at this particular particle lang naman dito. And then, of course, this is the path of the particle, and which is known. Okay, for our main purposes, we're primarily gonna be dealing with almost circle-like path, Okay, so we have some formulas, of course. So there we go. So if you recall this is velocity vector. Essentially, it's the magnitude of the velocity times its unit vector, ut, which is v over v. It's kind of weird. Okay, and then of course, the magnitude of v is simply just the ds over the derivative of position s, ds over dv. And then of course, we have direction v, which is always tangent to the path. Okay. Don't worry about it, but you'll understand further when you're trying to apply its equations lang naman dito. Okay, so this is particular it. Okay, and then we also have yung acceleration. All right, so in this particular case, this is pretty much straightforward, pero something lang na I need you guys to remember is that the normal perpendicular is represented by the perpendicular acceleration, or your normal acceleration is an, and its formula is the square of v squared over its radius of curvature, represented by Greek symbol rho. So rho here is ito yung mano-manong way to compute it, dy over dx lang naman to. Normally given siya. Okay, but sometimes it's not. Pero I have sample problems na. The other acceleration naman dito is meron tayong tangential acceleration, or yung parallel, denoted as at. So essentially, this is yung v dv over ds lang naman siya. Okay? Okay. And then, of course, yung magnitude ng a dito is simply the square ng perpendicular acceleration plus ng square ng tangential acceleration. Okay, but more on that later on the practical side pagdating sa problem solving. So let's try solving. I think I have 2 sample problems dito, and that's about it. Okay. Okay. So let's try solving the problem, applying yung normal and tangential tangential formulas natin, both velocity and yung velocity and yung acceleration. So for velocity is quite simple. All we have to do lang is find yung initial velocity niya, and then let's just check tayo mga components. Let's just go back lang a bit. So let's go back lang dito, and we have this velocity dito. See? All we have here, if we have components, we just need to know yung Vx, Vi, and kung meron siyang third axis, yung Vz. And we just need the square root there, get the sum, and then square root natin. Yun na yung magnitude niya. Or in this case, we get the magnitude of velocity by getting yung derivative ng position, or the change in position over time. But with acceleration, and gaya na sinabi ko earlier, we have to consider yung tangential acceleration and yung perpendicular or normal acceleration, which is v squared over delta, which is v squared over rho. which is yung radius of curvature. So in applying yung formulas na yun, so we have yung given natin dito, which is 2 meters per second squared. Here, this is tangential acceleration. Say, it's tangential, always tangential to the particle, to this particular component, to radius na to. And then we're here to find yung a, which is basically yung at squared plus an squared over the square root of the sums ng squares na yan. So we already have those, and recall an normal acceleration is v squared over radius of curvature, which is 1 meter. So that's gonna be 2 meters squared, 2 meters per second squared. So may correction dyan. Sorry, that's velocity. So 2 meters per second. So and then square natin. So that's gonna be 1 meter, and then that's gonna be 4 meters per second squared, and then you will get 5 meters per second. So let's just double check lang yan, which is 3 squared plus 4 squared. Yeah, 5 meters per second. So ito yung pinaka-straightforward na solution na ito. Okay? Let's have another problem naman. Okay? What if we have an equation of a line, which is velocity equals to 4t squared plus 2 meters per second. And we're here to determine the acceleration when the time is 1 second. Okay? And where t is in seconds. So we have here 6 meters naman dito. So we have a radius of curvature of 6 meters. Okay, so if you recall, we can get at by v dv over dt. Yeah. So ito yung mga equations na gagamitin natin. So to get yung acceleration, we need yung the square root of the sums and squares ng tangential acceleration natin and normal or perpendicular acceleration natin. Whereas yung at is simply the derivative of v. Oh yeah, so yung pala error doon. So wait, may mali ako dito. So yeah, ang mali ko dito, this one is supposed to be equals to. So where's that? Where's my PowerPoint? There we go. So this one should be lagyan natin siya ng accents. It's supposed to have a dot dito. So that's V. Wait natin kasi. There we go. On the spot editing. And then it should be equals yan. Yeah, there we go. So tangential acceleration lang naman natin dito. It's just simply the derivative ng velocity. Okay? At least an equation of the line naman dito. So we're going back sa problem. Here we are. So we can, and then yung and then yung normal acceleration natin, or perpendicular acceleration, is equals to v squared over radius of curvature, which is 6 meters naman. So this is pretty straightforward. So all we have to do is just get the derivative lang nito. So 4t squared plus t we describe to dt. So we get 8t meters per second squared. And where t is equals to 1, so that means yung tangential acceleration natin is 8 meters per second squared. So we just substitute lang naman yung 1 dun. And then for an, we just simply get the square lang naman ng v squared. Okay? So in this case, we square this one. And we get t is equals to 1. And we will have 6 meters per second squared. And then we just simply get to the square of the sums of tangential and normal acceleration, and we get 10 meters per second squared. So that's one of the ways lang naman din. Pero what if hindi siya ganito? Okay, what if let's put it in an oval, kind of like an oval racing. Okay, so let's put it in a real life scenario na naman. Okay, boom. So wala na no animation na nilagay dito. So or rather I forget. So makikita mo dito, so meron tayong, ito yung visual representation kung nasaan yung tangential, and it's better to, let's put a focus lang muna dito, no? So dito natin makikita yung focus. Yeah, there we go. So meron tayong yung tangential component ng car, and then meron tayong normal component ng normal acceleration ng car, and then of course ito yung magnitude niya. Okay? So ito yung components niya. No? So AN and AT. And then of course, ang maganda dito, we have yung radius of curvature niya. Kaya ba natin usog yan? So may yung axis T dito, yung axis N. And then of course, we have a radius here of 300 feet. So that will be our radius of curvature. So balik tayo sa problem. So we're being asked dito, lang naman dito to actually, yeah. So we're here being asked kung ano yung speed at this particular instance, okay? So we have a race car, C, that travels around the horizontal circular track. Just imagine a circular yan. Medyo naka-angle siya. So meron siyang radius of curvature of 300 feet. Ito yan. If the car increases speed, it's constant at a constant rate of 7 feet per second squared, starting from rest. Okay, starting from rest. Determine the time needed for it to reach an acceleration of 8 feet per second. Okay, from 7 feet per second squared to 8 feet per second squared. Okay, nagkaroon ng increase ng acceleration. Pag nagkaroon ng increase ng acceleration dyan, yeah. So, ano daw yung time dun? So, and then at this particular instant, ano daw yung speed? What is its speed at this particular instant, at this particular time to reach 8 feet per second? So, recall natin, ito yung mga givens natin dito. We have radius of curvature at 300 feet. Let's go back to our laser pointer. And we have an acceleration dito of 8 feet per second squared. And then we have a tangential acceleration of 7 feet per second, so constant rate. Keyword being constant rate. And then we're required to find yung total, yung determine yung time from 7 feet per second squared to 8 feet per second squared, and then velocity at this particular time, okay, or this speed at this particular time lang naman, since we're not referring to direction lang naman rin eh. Okay? So recall yung solution natin dito, which is VF equals to final equals to initial plus acceleration times time t. We know that yung at constant rate, initial starting from rest. So initial velocity natin is 0. And acceleration natin dito is 7 feet per second. And so initially, ang velocity natin is, final velocity natin dito for 7 feet per second squared is 7t. Okay? For 7t. Okay? And now to get yung AN, ito, yung normal acceleration niya, we use yung formula natin ng v squared over radius of curvature. So that will be 7t over 300. So that's gonna be 0.1633 t squared. Okay. And to get that, ang A natin dito, simply yung magnitude, which is, yung A natin dito, time to reach acceleration 8 feet per second squared. That's basically yung A natin dito. A. Okay? Alright? And then, 70 squared plus 0.1633 t squared. Okay? And then square both sides so maging 8 squared to. And isolate natin yung t. So yung time it takes to reach 8 feet per second squared is 4.87 seconds. And then to determine the velocity at this, so we substitute yung 8 sa 7t equation, which is 7 times 4.87, which will give us a 34.09 meters per second. And that's pretty much yung lesson natin. After this, I'll be posting your problem sets, so abangan nyo lang yan. So feel free to review this lecture recording and then or the PDF as well, and then or go over the books that I provided as well with you guys. That will be all.